Let's enhance the bank account such that we want to record the joint account holder as well. So here in a method, a function, we do void set joint owner, and then we want to pass name of the joint account holder and then age as int. So those information should be same as the person structure. So what you want to store is a person, but we want to just store pointer to joint owner. Like the reason why I want to have a pointer is this account may not have a joint account owner at all. Then in that case, we can simply store null value called the null pointer. Then if there is a joint account holder, we want to create the person object dynamically, and then we want to attach that. So if the structure of the person is big, then we can save memory if joint account holder is not present. So let's give implementation of those ones. Void bank account set joint owner where name and then age are provided. Then at the very beginning, when you create the bank account, we need to initialize the P joint owner. So here P joint owner is null PTR, not initialized. So C++ keyword null PTR is zero address value. It's not an integer, it's address of zero. So pointer is pointing to an address. Remember that. So it's something like initial value. There is nothing being to point. That is a meaning of a null pointer. So here we do same thing. P joint owner is null PTR. Same thing. Here we do that. Then these are initialized. So set joint owner is a P joint owner. We just dynamically create person object with a name and age. It's there. Then when you look into the bank account object, if a P joint owner is a null pointer, then there's no joint owner, but it's not, then the person, joint holder information is there. So there. And then if you remember, anything dynamically allocated, it should be deleted when you are done with the bank account. Otherwise, there is a memory leakage issue. So to trace that, let's have some mechanism. So to trace that, so in person class, whenever the person object is created, it's a constructor, then let's say something about that. So here, let's say cout person class constructor is created. So this one is called cout is defined iostream using namespace std is there. So this is the one of the constructor, and then here is another constructor. So let's print the information there. Here what you do is a name string and int. That's the constructor being called. It's there. And then when the person object is removed from the memory, C++ has a special function called. So when an object of a class is created, one of the construct is called when the object is deallocated from the computer memory or it dies, then another special function is automatically called, which is opposite of a constructor. We call it as a destructor. Destructor function name is a tilde and class name. It does not take any arguments at all. So that's called the destructor. It's there. So destructor is called when the object of this class dies. So let's implement destructor as well. Class name, colon, colon, function name, tilde, person. That's the destructor. So let's do cout, person, person. So this is a destructor is called. Is there. So whenever a person object is created, one of the two construct will be called, and then that person object dies, destructor should be called. So in this program, as a set bank account, that set joint owner is called, then a person object is created, assigned, and then when the bank account is no longer used, the person object should be removed from the memory as well. So to find what's happening, so let's call like B1 set joint owner and then give a joint name, age, whatever, like that. So let's call once and then compile the program and see what's happening. So person constructor 1, 2, 3, 4 called destructor 1, 2, 3 only. So we have a more creation than destruction. So something memory leakage happened. So to narrow it down the cause of that, let me comment those two lines out and focus on B1 only. Compile and run. It says two-person construct is called and the one destructor. The reason is that when this bank account B1 is called, it's a bank account. So this one, main program, B1 is default constructor. So default constructor is called owner is created. So here at this moment, the owner is a person type, so that person is created. So the first one, person is created. And then when you call set joint owner, so bank account, set joint owner, inside of that we create another person object. So that's a second constructor call. And then when program ends, so when program ends, bank account is removed from the memory, deallocated or destructed. When the bank account object dies, the owner also dies as well, because owner is just a variable of a class type called object. However, the one created dynamically by new, it is not removed from the memory. It's not destructed because if you create object by new, you have to explicitly delete it. Otherwise, it's not deleted, like as you can see. So then how do you take care of this part? When the bank account is used and then it's no more needed, when bank account dies, this person should die and then bank account should be removed. So to take care of that, we need the destructor of the bank account. Bank account destructor. So in the destructor of the bank account, as we implemented here, bank account destructor, then what you need to do is when this current bank account is removed from the memory, deallocated or dies, it has to free all the memories it has dynamically created. That is a person joint owner information. So at this moment, the keyword is delete p joint owner. We need to deallocate the person object for joint owner information. Then let's now compile the program and then let's run it. Then now we have another destructor called that is a bank account destructor freeze the person object. So that's called. So now we have a matching construct object creation and object deallocation. So we no longer have a memory leakage.